Here are two words you've heard a lot lately that my next guest thinks are often misunderstood. Artificial intelligence. Dr. Max Tegmark thinks that's a real problem. Dr. Tegmark is a physicist and AI researcher at the Massachusetts Institute of Technology and president of the Future of Life Institute. He thinks that AI is a technology that has the potential to transform life on Earth, maybe even what we mean by life on Earth. And Dr. Tegmark thinks that the decisions we make today about the future of AI will shape life in the next 30, the next 100, even the next billion years. So we better understand what we're talking about and not be distracted by fantasies about killer robots. He explores all of this in his new book, Life 3.0, Being Human in the Age of Artificial Intelligence. Dr. Tegmark, welcome to Quirks and Quarks.
Thank you. It's a pleasure.
So what is Life 3.0?
So that's a great question. First of all, what's life? My kids' school books give a very narrow definition of life that requires it to be carbon-based and made of cells. But from my perspective as a physicist, I really don't like this carbon chauvinism because I think I'm just a blob of quarks and electrons like all other objects in the world. And what's special about living things is what they do, not what they're made out of. So I define life more broadly, just as any information processing entity that can retain its complexity and replicate. And when a bacterium replicates, it's not replicating its atoms, but information, the pattern into which the atoms are arranged. So I think based on that, you can think of life as 1.0, 2.0, 3.0, depending on what the deal is, whether hardware and software. So life 1.0, it has both its hardware and software fixed by Darwinian evolution, like bacteria, can't learn anything during its lifetime, boring. Life 2.0, that's us. We're still stuck with evolved hardware, but we can learn. So we can effectively choose to install new software modules. Like if you want to become a lawyer, you go to law school and install a bunch of legal skills into your brain. And it's this ability to design our own software that's really enabled cultural evolution and human domination of our planet. And finally, Life 3.0, you can guess what it is now. It's when you can design not just your software, but also your hardware to really completely break the shackles of evolution. We humans are kind of heading in that direction. Maybe we're at Life 2.1 right now because we can make little upgrades like cochlear implants and artificial knees. But as much as I'd love to, I still can't install 1,000,000 times more memory or think 1,000,000 times faster. Whereas if you could make an artificial intelligence version of us humans, then there's no limit whatsoever to how you can upgrade yourself.
Well, that interest that you have in our artificial intelligence future is shared by a lot of big names, Stephen Hawking, Elon Musk, and other great scientists and technological leaders. Why is this such a preoccupation for you and people like them?
A lot of people who don't think this is a big deal are stuck in this traditional view of intelligence as something mysterious that can only exist in biological organisms, especially humans. But from my perspective as a physicist, intelligence is just another kind of information processing performed by elementary particles moving around according to the laws of physics. And there's no law of physics that says that one can't build machines more intelligent than us in all ways. So I really don't like this sort of carbon chauvinism that says that artificial intelligence can't be as smart as us. And I think we've only seen the tip of the intelligence iceberg, and that there's really this amazing potential to unlock the full intelligence that's latent in nature and to use it to help humanity flourish or to screw up in new ways.
Well, what about some of the dangers that people express, especially people like Elon Musk and Stephen Hawking, that this stuff could do some harm to us if it gets out of control?
It's the same with any technology, really, that you can create a great future with it as long as you win this race between the growing power of the tech and the wisdom with which we manage it. Now, the difference is that in the past, when we've invented fire, for example, we learned from mistakes to keep our wisdom up. After a while, we invented the fire extinguisher. But with more powerful technology, like nuclear weapons or superhuman artificial intelligence, we don't want to learn from mistakes. That's a terrible idea. We want to plan ahead and get things right the first time instead, because it's probably the only time we'll have. And that's what I think is so interesting to do today. Not to quibble about whether you should worry or not, but to ask, what things can we do right now to increase the chances that we'll get things right?
Get things right the first time.
Exactly. So this is not a safety engineering So let me back up a little bit. When we sent astronauts to the moon for the first time, it wasn't very shocking that they didn't die or that things worked out. Rather, it worked out because NASA had planned ahead with good safety engineering, trying to figure out everything that could possibly go wrong and then make sure it went right. And I think we're a little bit too flippant now with AI and not being quite careful enough. Anyone who has had their laptop crash on them at some point probably just felt that was annoying, right? But if this computer that crashes is in charge of your self-driving airplane or your nuclear weapon system or so, it's not so funny anymore. And we really need, for starters, to figure out how we can transform today's buggy and hackable computer systems into robust AI systems that we really trust. These are research questions, and we should really focus a lot of research effort on them so we get the answers by the time we need them.
Well, let's get to the core here, the definition of this term, artificial intelligence. Your book is called Life 3.0. So what does AI mean to you?
I define intelligence simply as how good something is at accomplishing goals. What we have now is machines that are getting better and better at very narrow kinds of intelligence, like driving cars or recognizing images, but nothing that can compete with a human child still in terms of broad intelligence. The ultimate goal of the AI field is to create intelligence in machine form that is as broad as human intelligence and can ultimately learn anything. If that happens, it's obviously going to transform the world as we know it, and poses a whole set of new interesting challenges. And it also, of course, opens up the possibility of great things happening, because everything I love about civilization is a product of intelligence. So if we can use artificial intelligence to amplify our own, then I think we can use it to solve all these pesky problems that have stumped us so far.
Well, how do you see this sort of general intelligence, artificial intelligence manifesting itself that goes beyond just self-driving cars?
We already know what general human level intelligence is like in some examples, because people around us have it, right? If you imagine that you could build a machine that could do exactly everything that a person could, it would immediately transform the economy, because you could hire these machines and they would work 24 hours a day for just the electricity it costs to power them and dislocate a lot of jobs. You could also use these machines to figure out much faster than humans can how to invent new technology. The technology is very powerful, but that doesn't mean it's necessarily good or bad. That entirely depends on what sort of goals we put into the machines. And I find Hollywood movies, they keep making us worried about the wrong thing, about some evil, some robots turning evil and conscious and deciding they don't want us or whatever. The real concern, I think, is not malevolence, but competence. Since super intelligent machines, by definition, much better than we are at accomplishing its goals, whatever they might be, right? We have to just make sure that its goals are aligned with our goals. Like we humans, for example, at least me, I don't hate ants. I'm not going to go out of my way stepping on one if I see it in my garden, right? But if I'm in charge of a hydroelectric project in Canada and I notice there's an ant hill there just before I flood the valley, too bad for the ants. And I want to make sure that we humans don't end up in the position of those ants. And rather that when we make machines, we make sure that they have goals that are aligned with our own goals so that they end up helping us.
Well, what's the difference between designing a machine to do a job and one that has goals? And where are those goals going to come from?
If you build a very intelligent robot and just give it a very simple job, like go shopping for me and cook a really delicious Greek dinner, now it has a goal because you gave it a goal, right? And it's smart, so it's going to break this into a bunch of sub-goals, like go down to supermarkets, pick out stuff, and so on. And now, if someone tries to stop this robot and destroy it, it's going to resist this and defend itself, because it knows if it gets destroyed, it's not going to accomplish its goal of making you dinner, right? So what this shows is that things that we might think are just typically human goals, like self-preservation, for example, they'll emerge very naturally. So it's very crucial to make sure that we have a way of making the machines actually understand our goals and then learn them. And that's harder than you might think. If you tell your self-driving taxi to take you to the airport as fast as possible and you get there covered in vomit and chased by helicopters and you say, no, that's not what I asked for. And the computer replies, that is exactly what you asked for. Then you realize how hard it is to teach goals to computers, right? Because a human taxi driver would have realized that you had additional goals besides just speed of delivery, because she's also a human. But a machine knows absolutely nothing about what it's like being human. And there's a lot of research now trying to crack this nut of how machines can actually, by observing us and so on, figure out the whole picture of what we really want.
Well, you talk about superintelligence in your book, that where the machines become so advanced and so sophisticated that they're beyond human intelligence. So what about the machine coming up with its own goals?
That's another fascinating challenge, because even if the machine first adopts your goals and then gets it way smarter, how do you ensure that it retains its goals? And we don't want machines who initially want to take care of us to get as bored with us as my kids got with Legos as they get smarter. So this is another fascinating research question. And what I think is kind of a shame is that the governments of the world are asleep at the wheel here. These are technical research questions that a lot of AI researchers would love to put their best grad students on, but there's almost no funding for it. Almost all the funding is just for making machines intelligent. Very little is focused on how we can just ensure that we have the wisdom to operate things rightly and get goals and so on. And it's a great opportunity right now, if we go in and fund this sort of research, to get the answers by the time we need them. Because even if superintelligence might only happen, say, 30 years from now, we want to make sure that if it happens, we have the answers by the time we need them. And it could take 30 years to get the answers. So I say, let's start now.
Will we be able to control a superintelligence?
There are two schools of thought on this. Some people think that what we should do is box superintelligence and have it basically locked in so it can't break out, and use it as a kind of enslaved god to do whatever we want for us, and just hope that the people who control it are good people with the best intentions. Other people feel that that's either immoral towards the AI or not a good idea for other reasons, and instead want to have an AI that's very smart and free, but just make sure that it actually has its goals to help us. That can also be okay, because little children tend to be in the company of intelligent beings that are actually smarter than them, namely their parents. And that's fine, right? Because the parents have the best interests of the children in mind. So if we can crack this goal alignment problem, that can also work.
Well, you do look into the far future. I mean, you look out billions of years into the future, and it's, in your mind, not just a human future. Is artificial intelligence our evolutionary future on a cosmic scale?
I certainly think that if one day life from Earth ends up spreading to other galaxies, it's much more likely to have gotten there with a lot of help from AI. As a physicist, I find it kind of fascinating that it's actually easier to say sensible things about what might happen in 1 billion years than about what might happen in 100 years. They are totally mind-blowing. There is just an incredible potential for the future of life. And most science fiction writers have been much too pessimistic in what we can ultimately do, because they've been so limited to this idea that if you want to go far away, you have to send a bunch of meat bags there and figure out a way for them to survive these ridiculously long journeys. When in fact, ultimately, I think life is information, and the much smarter way to do it is to basically email the information about your mind or whatever to other places and have yourself reassembled there with future tech. So sky isn't even the limit here if we really can harness AI for good.
Dr. Tegmark, thank you very much for your time.
Thank you for yours. It's been a pleasure.
Dr. Max Tegmark is a physicist and AI researcher at the Massachusetts Institute of Technology and president of the Future of Life Institute. His new book is called Life 3.0, Being Human in the Age of Artificial Intelligence.